Okay, so this is 4.2, and it is on reflections. So I'm going to go through these notes pretty quickly. So when you do reflections are a transformation that use a line like a mirror. So we're using M here as our mirror basically, and we're going to take P and we're going to reflect it across that line to get P prime over here. And when you do reflections, it's important to know that the distance from P to the line is the same as P prime to the line. So that's why those are little markings right there saying that those are congruent. So we did the example. We graphed ABC with A being at 1, 3, B being at 5, 2, and C being at 2, 1. We did the example of X being 3, so you're just graphing that. I'm going to do the next example for you guys. So A is at 1, 3. This is A. B is at 5, 1, 2, 3, 4, 5, 2. And C is at 2, 1. So here's my triangle. And I want to reflect it across the line, y equals 1. So here's y equals 1. Okay, that's my line of reflection. So you're just going to count how far your points are. So like A is 2 away from the line, so that means A prime has to be 2 away from the line on the other side. B is 1 away from the line, so B prime is 1 away from the line. Well, C is on the line, so to get C prime, you can't really move it anywhere because it has nowhere to reflect. So there's your reflection. Okay. So if it doesn't say like x equals 1 or x equals 2 or x equals 5 or whatever, then we have these specific rules here. So those are the rules you need to make sure you have. And remember, I'm going to give you sticky notes. So you will have the ability to do, you'll be able to write those down and have them for the test that way. So then it's just applying what those rules are. So this very first one says graph it if we reflect across a line y equals negative x. I'm actually going to clear this out so we can start fresh. So if that's the case, we have to know where FG is. Shoot. Okay, hang on. Let me reflect or get rid of all this stuff. Sorry. Okay. So, should have done a better job of this before I started. So F is here at negative 1, 2, and G is at 1, 2. So if I want to find F prime, I apply the rule for y equals x, well, or line y equals negative x. So when we go back to that page before, and if we're graphing y equals negative x, the rule is that AB becomes negative B, negative A. So that means I'm going to flip my point, so it becomes 2, negative 1, and then we're going to change the sign on both of them. So it's actually negative 2, positive 1. It's kind of hard to see, but I marked through that. Okay. And then for G prime, you're going to flip them, so 2, 1, and then you're going to change the sign, so negative 2, negative 1. So F prime is at negative 2, 1. So that's right here, F prime. And G prime is at negative 2, negative 1. That's G prime. And there's the reflection, F prime, G prime. So now we're going to our next example. And these I'm not going to graph, we're just going to kind of walk through them real quick. So if I'm going across the x-axis, the rule is that AB becomes A negative B. So we leave the x alone and we just change the y. So that means if J is at 1, 3, then J prime is at 1, negative 3. If K is at 4, 4, then K prime is at 4, negative 4. If L is at 3, 1, then L prime is at 3, negative 1. And then the rules for the y-axis are the same. Well, they have a different rule, but you'll basically do the same thing. Okay. So rigid motion, it says that reflections are rigid motion. That just means that the pre-image, so what we start with, and the image are going to be congruent. okay? So they're gonna be the exact same picture. So then our last example is doing a glide reflection, which is just a fancy name for doing a translation and then a rotate or reflection. So for my translation, that's what's here in the pink, okay? I start with A at 3,2, B at 6,3, and C at 7,1, and I just apply that rule. So the rule says I take A and I subtract 12, and then I just keep Y the same. So that's how I got A prime, B prime, and C prime. And then you take A prime, B prime, and C prime, and then do the reflection piece of it. And so that's how I got those points right there. Lines of symmetry, that's just how you map it onto itself. So for this first picture, you can only cut it in half. But on the hexagon, like, you can do a bunch of them. And then this little airplane thing over here, it only has one. So our homework for this section was page 186, 3 through 23 odd.